Hi everyone, how are you doing? How is your progress with building your profile using geeks4geeks.org or leadcode.com? I hope you're doing great and all the best with your job interview. Today I'm going to go through with you a problem whose title is Pythagorean Triplet, and this problem was delivered by Amazon and Adobe. So we are going to be given a list of numbers as the input of our program, and you have to find out whether there exists a Pythagorean triplet P, Q, and R where this condition is met. P to the power of 2 plus Q to the power of 2 is equals to R to the power of 2. And we call the longest side hypotenusa or R, and the other two sides next to right angle we call it P and Q. So in this example, you can easily find that such Pythagorean triplet exists where P equals to 3 and Q equals to 4 and R equals to 5, i.e. 3 to the power of 2 plus 4 to the power of 2 is equals to 5 to the power of 2. Hence, you can find such triplet, then you have to return yes at the end of your method call. At this example here, you cannot find such triplet, hence you have to return no because you cannot find PQR such that P to the power of 2 plus Q to the power of 2 equals to R to the power of 2. So we are also given a time limit where you should deliver a solution that runs at order n plus max array I to the power of 2. I don't understand this max array I to the power of 2 part, but I do have a solution that is being accepted by the geeks4geeks.org standard. But before we are going through our solution, I'm going to explain why people having problem with passing a job interview like this. It's because they're using a brute force to deliver a solution. So I'm going to just go through with you the brute force algorithm part. Brute force check triplet. Here I'm going to use len array, and here I'm going to change the naming convention to be array and len array. Here don't forget to put self dot. Here I'm going to define such brute force algorithm array len array, and here I'm going for I in range 0 until the length of the array, and here I'm going to fetch number P from the array at index I, and we are going to have another inner loop in range 0 length of the array, and here we are going to fetch number Q from the array at index J, and here I'm going to go from range 0 until the length of the array, and we are going to fetch P, Q, and R from the array at index K, and R is the hypotenusa in this case. So if we check that I is not equals to J, and J is not equals to K, and I is not equals to K, and P raised to the power of 2 plus Q raised to the power of 2 equals to R raised to the power of 2. Hence, you have found a Pythagorean triplet in this array. Hence, you have to return true. Otherwise, where you cannot find any Pythagorean triplet, hence you have to return false. And let's just submit this code and see how it's worked. So you pass the test case until the test case number 10, and you fail at the test case number 11 because you have a time limit of 4.25 seconds. So let me explain to you what is the complexity of this algorithm here. So here you're going to take order n, and this inner loop is going to take another order n, and this is another inner loop where you have to take another order n. So altogether it's going to take order n cubed. So it goes far beyond the limitation of our time complexity. So we are going to forget about this. So let's just comment this, because we are not going to deliver a brute force solution during our job interview, and we are going to solve this solution using Pythagorean triples. So here I'm going to use a method, check triplet, using Pythagorean triples. Here, let's define such method using Pythagorean triples. And here is our to-do list. So what is Pythagorean triples? You can type Pythagorean triples in the Google search engine and you will get a website called BYGU as one of the top result in the list. So here BYGU will list you all the Pythagorean triples. Here is Pythagorean triples where C is below 100, and here is another Pythagorean triples where C is above 100 as being stated here. So is this all the Pythagorean triples that exist in the world? Yes, there is no other Pythagorean triples outside what is listed in this table. So what is Pythagorean triples? Pythagorean triples is three positive integers a, b, c, such that a to the power of 2 plus b to the power of 2 is equals to c to the power of 2. So the most well-known Pythagorean triples is 3, 4, 5, which is the one that is listed here. Another most well-known Pythagorean triples is 5, 12, and 13. And here you can check against the form of Pythagorean theorem. Here you just type in Pythagorean theorem inside the Google search engine, and it will give you a result of Pythagorean triples form. And you can check here when you add 3 to the power of 2 plus 4 to the power of 2, you will get 5 to the power of 2, which is a to the power of 2 plus b to the power of 2 equals c to the power of 2. And here you can just copy paste this and check whether this is another Pythagorean triplets. 5 to the power of 2 plus 12 to the power of 2 is equals to 13 to the power of 2. And here you can also check to see by copy pasting 8 and 15 inside the field of A and B, and you will get 17 as the C. So and so on and so forth until you reach the end of the table. So for example here, if you type in 115 in this text field and 252, you will get 277. So here we are going to use the naming convention accordingly with bygu.com website. So we are going to use Pythagorean triples, we are going to use ABC, we are going to use what else? PQR. So what is PQR? P is when you have A multiplied by a factor, and Q is when you have B multiplied by a factor, and R is when you have C multiplied by the same factor. So I'll give you an example. Here we are going to fetch the most well-known Pythagorean triples, and let's multiply it by a factor of 2. All these three numbers has to be multiplied by the same factor. Here we multiply 3 by 2, you will get 6. Here you'll multiply 4 by 2, you'll get 8. Here You multiply 5, you'll get 10. And you can see, you can check out that 6 to the power of 2, which is 36, plus 8 to the power of 2, which is 64, that is equals to 100, that is 10 to the power of 2. And so you can check that p raised to the power of 2 plus q raised to the power of 2 is equals to r raised to the power of 2. And also, this also applies when you multiply these two numbers by the same factor, 3. So 3 multiplied by 3, you will get 9. 4 multiplied by 3, you will get 12. 5 multiplied by 3, you will get 15. And you can check that 9 raised to the power of 2 plus 12 raised to the power of 2 is equals to 15 raised to the power of 2. This is 81 plus 144 is equals to 225. So let's begin our implementation using this naming convention. This is going to help you to better understand how this algorithm works. So let's define Pythagorean triples list. And here I have defined such a list. This is derived from the table that we see in BYGU website. So oops. I'm afraid I'm going to fail the indentation. Let's just submit this code to check whether we don't have any problem with the indentation. Invalid syntax. Pythagorean triples list. Sorry about this. I'm very sorry about this because I'm using a different naming convention. Here I just test whether we have no problem with the indentation. So we don't have any problem with the indentation. So okay. And then we are going to iterate. For each Pythagorean triples in Pythagorean triples list, and we have to check whether we can find is Pythagorean triplet found. And here we are going to check against the array of the numbers, and here we are going to pass the Pythagorean triples. And if we can find such triplet, we have to return true. If you cannot find any such triplet, we have to return false. And here let's just define our helper method is Pythagorean triplet can be found, and here we pass self, array, and the Pythagorean triplets. And by now you should be familiar with the Pythagorean triplet. It is one that is defined in this list here, so I can take the first three. So Pythagorean triplet is any of this tuple that is defined in the list of Pythagorean triples. So this list is derived from the table that is listed in bygu.com. So you take 3, 4, 5 and you put it inside the list here, 3, 4, 5, and next you will fetch 5, 12, 13, and you will put it inside the list 5, 12, 13, and so on and so forth until you reach the end of the table where you put 115, 252, and 277 on to the end of this list. So this is how I derive this list right here. So here is the most complex stuff. I hope you focus on this. Here I'm going to close it. Here I have to find a hypotenusa. So RS is equals to list comprehension of R for R in array, where R, when you divide R with the Pythagorean triples at index 2, you will get 0 remainder. So you know that a hypotenusa exists, and the rest you have to find P and Q. You have found the R, and the next thing you will have to find P and Q. And how you are going to do it? First you have to find out what is the factor. The factor is when R is divided by the Pythagorean triplet at index 2. So here is the Pythagorean triplet at index 2, which is 5. So for example, you find a hypotenusa 10, and hence the factor is 2. And here you have to find such number P for P in array in array if P when it is divided by the factor, that gives you a triple stump Pythagorean triplet at index 0. So here you find a hypotenusa, but you have to find another two numbers P and Q. So first you have to find the P. So P is equals to P, where P divided by a factor, which is if the hypotenusa is 10, the factor is 2. So you can find a number that is 6. So 6 divided by 2 is equals to Pythagorean triplets at index 0, which is 3. So here I have to also find the Q for Q in array. If Q divided by a factor, that gives you a Pythagorean triples at index 1. So For example, you have found a hypotenusa 10, and you can calculate the factor by dividing 10 against 5, and you have 2. In this case, you have to find the number 8 in the list of numbers where 8 divided by 2 is equals to 4, which is the Pythagorean triplet at index 1. So far, so good. So this is not so hard. If you can find such number PS, and you can find such number QS, you have found a triplet, isn't it? And if you cannot find, just return false. And okay, let's just submit the code and see how it works. Okay, that's okay. Return true. Oh, we forget about and this will eventually pass the test case because the total time taken is less than the time limit that is given by geeks4geeks.org, which is 4.25, if you can remember. So I hope this is clear. This is very neat algorithm. I'm trying to use the same naming convention as the one that is defined in BYGU, so Pythagorean triples, and I'm using Pythagorean triples in this program. And also I have used the P, Q, and R in this case, and here I use R, P, and Q. Have a close look into this document BYGU Pythagorean triples, and you will understand very easy my software. Okay, thank you very much. Have a good luck with your job interview and all the best with your future. Thank you very much. Bye.